So you know that the graph y equals 5 over x squared looks like that, it's symmetrical. And you know that the graph y equals 2 take away 4x has an intercept on the y-axis of 2, a gradient of -4, so it's going to hit the x-axis at a half. So you need to be able to draw the modulus of that. So it's going to be a graph that looks like that, so that you can see the bit that's been reflected. I've tried to put in there as a dotted bit that's been reflected. Now I would definitely put these in my graphical calculator to get a really good idea of how the graph is going to look. So you can see I've drawn the two graphs on the same axes, and this is what it's looking for. It's 3 marks. So it's, you know, you've got to think, it is something you can put in your calculator, so show enough detail to get the 3 marks. I think you're going to get a mark for correctly drawing y is the modulus of 2 minus 4x, and a mark for drawing, you know, make sure it doesn't touch the x-axis, your 5 over x squared, and then clearly indicate, like I have done, where you've got the 2 roots. Right, the part that we're looking at now is, so part 2 is you're talking about the positive root. Now the positive root, so that's the positive root that I've marked there, is where the graph of y equals 5 minus x squared, which is that curve, meets the reflected bit of y equals 2 minus 4x. You know that when you reflect in the y-axis, which is what you're doing here, you multiply the whole equation by -1. So this graph here, if you want to look at it, is -1 times 2 minus 4x. That's the way we would think about it. So that's the reflected bit of that line. So using your transformations of graphs, it's -1 times that. And that's you want to know where that meets 5 over x squared. So from now on, this is just an algebra question, this bit here. So you're finding where they meet. I'm going to expand that bracket with the minus. I'm now going to multiply everything by x squared. So that's going to give me that. Then obviously I gather everything together, and I've got the answer that it wanted to show me, that you had to show. I think this bit though was key. You needed to spot that the positive root was found from the reflected bit in the y-axis of y equals 2 minus 4x, which is -1 times that. Right, so there's your f of x, because it's telling you that f of x equals 0. It then asks you to form the Newton-Raphson. Now, Newton-Raphson is new to A-level, so it's very likely that it's going to be on. You will be given this iteration formula for Newton-Raphson, so you don't have to learn it. So you can see that that's how they're forming it. So all you're going to do is you're going to take f of x, which is that. You're going to differentiate it, which is obviously pretty straightforward. You're now going to put those in the formula. The only thing that's slightly different is that little subscript of an n. So you're going to end up with x, the n plus 1th term is x nth term with your f of x, and underneath you've got your f dashed x. Now I'm going to have to combine those, and you can see it's algebraic fractions. You're doing a subtraction. And to make my life easier, I've written x with a little n, because in theory that's like the whole bit. I've written that over a denominator of 1. And now it's literally algebra. You're combining those over your common denominator. So put them over your common denominator using your laws of fractions, and then multiply out those top brackets, just being really careful with your signs. So follow what I've done there, which is just algebra, and then you end up with your iteration formula, and the rest is straightforward.